Hello everyone, today we're discussing Atcoder's beginner contest 393. We're discussing the fourth problem of it, the D problem. So the problem statement is given here. The problem statement states that we are given a string S of length n consisting of 0 and 1. Okay? It is guaranteed that S contains at least one 1. Alright, so 1 is present in the string. Now what we need to do is we need to perform the following operation any number of times. Okay? So the operation states that choose an integer I, choose any index, and swap the ith index and the I plus 1th index characters of S. All right. So we need to swap the ith index character and the next character, the I plus 1th index character. Right. We need to swap both of them. Now we need to find the minimum number of operations needed such that all the ones are contiguous. Right. So the all the ones should be clubbed together. All right. So ones of the string should be clubbed together and zeros of the string should be apart. Okay, so this is what we need to do. So let's take an example and you'll understand it better. So let's say the string is this one. So 0 1 0 1 0 0 1. All right. So as you can see, if I swap both of these, all right. So let's say I swap both of these. All right. So one comes here. All right. So one comes here. Zero comes here. All right. 0 0 1. So how many operations did I did? I did one operations. Now next, what did I do? I swapped both of these. All right. So one came here, right? So one came here. So I did one more operation, and then I swapped all both of these. All right. So one came here then. Right? So what did I do? I clubbed all the ones together. And how many operations did I do? I did three operations in total. Right. I swapped both of these. Then I swapped both of these, and I then swapped both of these. So how many operations did I do? I did three operations. And if you do all the calculations, 3 is the minimum possible number of operations that you can do such that all the ones are clubbed together. All right. So the answer for this case is 3. All right. So are you getting the question? What the question is trying to say? All right. So let's take another example and you'll understand it better. So let's say the example is 1, 0, and 0. So as you can see, there is only one 1. So if you look at this, there is no one other than this. So the answer for this case is 0. We do not need any operations. So no operations. Okay, so no operations needed. Let's take another example. So the answer for this case is 0. Let's take this example. This is a nice example. So 1 0 0 1 0 0 1 0 0 1. Now, if you look closely, which one should we club together? All right. So if you think we need to club all of these ones together, so let's club this one and this one together, and this one and this one together. All right. So I'll just club these ones together. All right. So what do we do? How much movement does this one do? All right. So this one is going by one places. So there must be one movement. All right. So this one will come here. All right. Then this one will come here. So it is moving by two places. All right. So two, and then for this is one. This one is traveling five times, right? So sorry, four times. So 1, 2, 3, and 4. All right. So four operations. So what I'm trying to say is this will swap with this. So one will come here. So one operation. Then this one will swap with this one. So one will come here. Then this one will swap with this one. So one will come here. Then this one will swap with this one. So one will come here. Now, as you can see, all the ones are clubbed together, right? All the ones are clubbed together. So how many operations did I do? I did 7 operations in total. And this is the minimum number of operations that I can do, right? 1 plus 2 plus 4 is 7. All right. So this minimum number of operations is 7 in this case. All right. So what I'm trying to do is, let's write the original string. What I'm trying to say, okay, is this one. All right. So let's say this is the example. The extremely brute force of this solution. What would be the brute force of this solution? Like I'm moving once, right? I'm moving once somewhere, right? So I just need to club all the ones together, right? That is what I need to do. So what I'm trying to say is ki let's look at from another perspective. All right. So let's say this zero is moving somewhere, right? So if this one is coming here, then this zero is coming here, right? So by how many places is this zero moving? This zero is moving by one places. And if you look closely, how many ones are here? How many ones are in this substring? There is only one one. And how many ones are in this substring? There are three ones, right? So there is only one here and there are three ones here, right? Three ones, 1, 2, and 3. So there are three ones here. So obviously for this zero, it is optimal to move to this place, right? So it is optimal to move this place. So can I say that for any zero, the most optimal solution would be, the most optimal movement for it would be the minimum of left ones and right ones. The number of ones on the left of that zero, right? How many ones are there? 1. And how many ones are here? 3. So by which direction will it move? It will move in the left direction. So it would be optimal for this 0 to come here. So then this one would become here, right? That is what we are doing, right? So actually what I'm trying to do is, okay, I will not swap any of the thing, right? I'm not swapping any of these. I'm just calculating the operations, right? I'm just calculating all the operations. I'm not swapping any of the ones and zeros. Okay. So what I'm trying to say is ki, let's say this is swapped, right? So one will come here, right? And zero will come here. So one will come here, then zeros come here, right? Let's say for this zero, what is the optimal solution, right? So as you can see, how many ones are in this place? Two ones, right? This one and this one. And how many ones in this case? Two ones, this one and this one. So the zero can move in any direction. So let's say that the zeros move in left direction. So what does it mean? Okay, this zero will come here. That's why this one will come here, right? That is what I'm trying to say now. Okay, the one and zero will replace each other's position. Then the zero that was here will get swapped with this one, right? So this zero will come here and this one will come here, right? That is what I'm trying to do. The number of ones on the right side were 2, right? So the number of ones in the right side were 2, right? This 2 for this 0. So you can it can go to any place, right? Let's say for this 0, what is the optimal solution? So there are 3 ones here and there is only 1 here, right? In this case. So the optimal case for this 0 would be to move on the right side. So if it moves to the right side, then this one will come on the left side, right? That is what I'm trying to say, right? So how many places did it move? 2 places, right? So it moved by 1 places. I can say this 0 moved by 1 places, right? And the 1 moved by 2 places, right? So that is what I'm trying to say. For any 0, count the number of ones on the left side and count the number of ones on the right side, and we will find the minimum of it. All right. So let's say I'm looping in the loop in the string. So I'm looping in the string, and I'm checking if the s of I character is 0. If the ith character is 0, then I will find the left ones. I will find the left number of ones, and I will find the right number of ones. Number of ones on the left side and number of ones on the right side. That is what I will find. And I will add the minimum of it to my answer. I will add the minimum of left and right to my answer. And then finally, I will print my answer. So print answer. Simple as that. All right. This is the code. This is the most brute force code that we can think of, right? So instead of thinking like let's club all the ones together, I thought in the opposite manner. So I thought, let's club all the zeros together. Like this zero will move in which direction? This zero can move in either direction because there is 2 ones here and 2 ones here. But for this zero, it is optimal to move to this direction because there is only 1 here and there are 3 zeros here, 3 ones here, right? So it is optimal for this zero to come in this direction. It is optimal for this zero to go, and it is optimal to go for this zero to come here, right? Matlab, it will stay here. It will stay here only, right? It will not go here because there are 4 ones here, right? So this zero will not go anywhere, right? So this is the code for it. Now let's do the C++ and Java code for the same. All right, so let's do the C++ code for the same. So please read the input function very carefully. First, we need to input the size of the string n, and then we need to input the string itself. So I'll input n and then the s, the string itself. So let's input n and s. So what we'll do in the solution is we will traverse in the entire string, and I'm checking if the ith character is 0, right? So what is the optimal solution for it? So I'll find number of ones on the left side and number of ones on the right side, right? So I'll find right ones and left ones. So how do I find left ones, right? So I'll traverse from j to 0 to j to I, right? And I'm checking if the jth character is 1, that means there is a 1 present. So I'll increase my left count. And for the same for the right side, I'll traverse from j equal to I plus 1 up till j equal to n. And I'm checking if the s of j character is 1, then I'm incrementing my right count. Now, the most optimal way for the 0 is to go either to the left or either to the right. So I'll add minimum of left ones and right ones to my answer. And finally, what I will do is I'll print my answer. Okay. So the initial value of answer is 0. So let's make an answer variable. So the initial value of answer is 0. Let's run this code. So it's taking a little bit of time. Let it run. Right. So as you can see, all the test case got submitted. Now let's submit this code. So as you can see, this solution is giving a TLE. It is giving a TLE because the constraints of this question is 10 raised to 5. And our solution is running on a time complexity of n square. So this solution will not get submitted. But there is also this another way of writing this approach. So instead of just for looping, there is this inbuilt function in C++. All right. So I'll show you the inbuilt function first. So finding the left ones, you can use the inbuilt function called count. All right. So I'll traverse from the beginning of the string to beginning plus I, and I'm counting one in the string. Same for the right ones. So I will traverse from I up till the end of the string. All right. And I'll add this one. So instead of using a for loop, you can also use this inbuilt functions. The time complexity will remain same, but you can use this inbuilt function for a better writing code. All right. So let's submit this approach. This approach will also give TLE, but I'll submit it anyway. All right, so as you can see, this approach is also giving a time limit exceeded error. So let's optimize this solution in the later half of the video. All right, now let's do the Java code. So please read the input for note very carefully. First, we need to input the size of the string. So next int. Then we need to input the string itself. All right, so I'll just input the string. Now, what we'll do next, what did I say? I will traverse in the entire string. I'll traverse in the entire string. And I'm checking if the ith character is 0. If the ith character is a 0. So I'll find the number of ones on the left side. So I'll find left ones and I'll find number of ones on the right side. So how do I find number of ones on the left side? So I will traverse from j equal to 0 to up till j equal to I. And I'm checking if the jth character is 1. That means there is a 1 here. So I'll increase my left count. Same for the right one. I'll traverse from I plus 1 up to n. And I'm checking if there is a 1. Then I will increase my right count. Now finally, I'll add the minimum of both of them in my answer. Right. So I'll just add the minimum of both of them in my answer. So let's make an answer variable. So let's make an answer variable. And for this case, it should be next itself. Okay. And finally, what I will do is I'll just print the answer variable. That's it. This is the simple code. All right. So let's run this. So as you can see, all the test case got passed. Now let's submit this code. So I'll just quickly submit it here. All right, so as you can see, this approach is giving us TLE. That is because we are using a time complexity of n square. And if you look at the constraints of the question, the constraints are 10 raised to 5. So time complexity of n square will not get submitted. So let's optimize this solution in the later half of the video. All right, so let's optimize this solution. So what are we trying to do? What are we trying to do? Let's say this is the string, right? So for this 0, I'm counting the number of ones on the left side and the number of ones on the right side of the 0. So what I will do is I will find all the ones in the string. All right. So I'll find all the ones in the string. How many ones are there? 4. Now, what I'm doing is I'm using a variable. Let's say the variable name is x. So let's say the variable name is x. Now, I will traverse in the string. All right. So I'll traverse in the string. This is a 0. All right. So I'll not increment x. X is the number of ones. All right. So we are counting ones. Counting current number of ones. All right. So this is a 0. So we will not increment x. This is a 1, so we will increment x. All right. Now, when we reach this 0, I will check if how many zeros are on the left side. So there are x number of zeros on the left side, and how many zeros are on the right side. There are ones minus x number of ones on the right side. Right. That is what I can say now. If the total number of ones are 4, right? If the total number of ones are 4, and there are 1 ones here. So how many ones would be here? There would be 3 ones here, right? Simple maths, right? So if there are x number of ones on the left side, then there are definitely ones minus x number of ones on the right side. Can I say it like this? So by using this approach, the time complexity of this solution will be reduced to O of n, and this solution will get accepted. So let's do the code for the same. So let's do the C++ code. So what I will do is I'll remove this part of the code. And first I will find the number of ones in the string, right? So I'll find total number of ones. So you can use the inbuilt function in C++, or you can use a for loop. So I'll just use the inbuilt function and I'll count the number of ones in the string. I'm also using another variable called x, right? So I'm using a variable called x. What is x storing? The current number of ones, current number of ones. So I'll traverse in the string. I will check if the ith character is a 1, then I'll just increment my x, right? Otherwise, what I will do is how many ones are on the left side? X number of ones. And how many ones are on the right side? Ones minus x, right? And I'll just add minimum of both of them to my answer, right? That is what I'll do. And finally, I will print my answer. So let's run this approach. That's it. This is it. This is the simplest code. This is the simplest code possible. Right, so it is taking a little bit of time. So let it run. And as you can see, all the test kit got passed. Now let's submit this approach. So I'll just submit it here. All right. So as you can see, the code got accepted. All right. So let's do the Java code. So what I will do is I'll keep this code as the same. So I'll just remove this code. And first I will find the number of ones in the string, right? So let's make a variable called ones. I will traverse in the string. I will traverse in the string and I'm counting the number of ones in the string. So I'm counting if the ith character index is a 1, then I'll just increment my ones variable, right? So that is what that is how we count one number of ones. Then I'm also using another variable called x. So what does x signify? X signify the current number of zeros, sorry, ones. So x is signifying the current number of ones, all right? So I'm checking in the string if the current character is a 1, then I'll just increment my current variable x. Otherwise, how many ones are on the left side? There are x number of ones, and how many ones are on the right side? Ones minus x number of ones. And I will add minimum of both of them. All right. So instead of just, I'll add minimum of both of them to my answer, right? And finally, I'm printing my answer. So simple as that. This is the code, as simple as it gets. Right. So as you can see, all the test cases got passed. Now let us submit this approach. So I'll quickly submit this approach. All right. So for some reason, it is giving a wrong answer. So let's check what's the problem here. So I'm counting the number of ones and current number. So if the current number is a 1, if s.character is a 1, then I'll increment my x. Or the number of ones in the left side is x, then number of ones in the right, 1 minus x, then left ones minus. It is correct, nah? The code is correct. I think so. It is correct. The C++ code for the same was also same as this. So let's check what's the problem here. I think there should not be any problem in the code as such. What if instead of using int, I'll just convert it into a long variable? So would that be possible? So I'll just convert everything into long. So let's use a long variable. So instead of using int, I'm just converting everything into long. I don't think so that should be a problem here, but let's submit it anyway. So I'll just use a long variable here. So let's submit this approach. All right. So as you can see, this approach got submitted. Now, for the time complexity of this code, as you can see, we are using only one for loop. So the time complexity of this code is O of n. The space complexity of this code is O of 1. We are not using any extra space, right? So what did we do? I will just show it to you in a quick bit. So for any zeros, I will find the number of ones on the left side, right? So number of ones on the left side and number of ones on the right side. So let's say the number of ones here are 2 and the number of ones here are 3. All right. So there are 3 ones here. So what is the optimal choice for this 0? It is optimal for this 0 to go here, right? It is optimal for this 0 to go here such that this one will come here. This one will come here, right? That is what we are trying to do. We are clubbing all the ones together now. So I used reverse logic. I said, which direction should this 0 go to, right? So I found out that this 0 should go to the left direction. Then what did I do is I will find the minimum of left ones and right ones. All right, that's it. Simple as that. So in case of these types of question, you should use a logic such as this. All right. So I'll see you in the next video. Till then, keep learning. Take care. Bye bye.